Welcome. This is the very first stop in practical machine learning with TensorFlow, so there's nothing behind us to call back to yet. Instead, let me hand you the map. Every single model we build in this course, whether it reads movie reviews, translates a sentence, or forecasts tomorrow's temperature, is the same journey down one track with 8 stops. Today, we stand at the very start of that track and look at the two things underneath everything: the tensor, the box of numbers data travels in, and Keras, the wheel you'll actually steer with. Here's the whole track: collect, preprocess, build, train, evaluate, save, deploy, predict, watch it light up left to right. Every model you'll ever build is just these 8 stops in this order. Some episodes spend their whole time at one stop, say preprocess, but the stop is always on this line. Keep this picture in your head, it's the spine of the entire course. So what's a tensor? Don't let the name scare you. A tensor is just a labeled box of numbers, one number on its own, a temperature, a price. That's a scalar, a zero-dimensional tensor. Line a few up and you get a vector, one dimension. Stack vectors into rows and columns and you've got a matrix, 2 dimensions. Stack matrices and you climb into 3 dimensions and beyond. Same box, more shelves. Every box carries a label and the label has 2 parts, shape and dtype. Shape tells you how many numbers and how they're arranged, like 2 by 3 for 2 rows of 3. Dtype tells you what kind of number, 32-bit floats, integers, and so on. Memorize this. 90% of beginner bugs in TensorFlow are a shape that doesn't line up or a dtype that doesn't match. Read the label before you blame the model. Why does a GPU adore tensors? Because the math inside a neural network is thousands and thousands of tiny multiplies and adds, and they don't depend on each other. A GPU is a giant grid of little workers that can all multiply at the same instant. Hand it a tensor and the whole grid shimmers to life at once. That parallelism is the entire reason deep learning became practical. Now the two names you will keep hearing. TensorFlow is the engine. It holds your tensors, runs them fast on CPU or GPU, and crucially, computes gradients automatically, which is how models learn. Keras is the steering wheel. It's the friendly layer that lets you say, give me a dense layer, then another, without wiring the engine by hand. They ship together tf.data, engine underneath, wheel in your hands. And good news for your sanity, modern TensorFlow runs in eager mode. That means it executes line by line, right now exactly like NumPy. You type a plus b, you get the answer immediately. No sessions to open, no computation graphs to summon before anything runs. What you write is what happens in order. That's a huge quality of life jump from the old days. Back to the spine, stop by stop, collect, get the raw data, pre-process and clean it, shape it, turn text or images into tensors. Build now, stack the neural network, train, let it learn from examples, evaluate, check it on data it never saw, save, freeze the trained model to disk, deploy, put it somewhere it can be called, predict, feed it something new and get an answer. 8 stops, that's the job. This whole course is just many laps of that loop. Each area, vision, time series, and especially natural language and transformers, deepens one or two of these stops with a real worked example. So, next episode, we won't linger on theory. We'll run the entire loop end to end in one sitting and watch a real model go from raw data to a real prediction. Let's prove all of this in code. One short file 01 hello tensorflow.py, about 20 lines. We'll import TensorFlow, make a few tensors, do real math on them, peek at their labels, and then in a single line summon a Keras model just to show how close the wheel always is. Follow the gold box as it walks each section. First the import and a sanity check. Import TensorFlow as tf, then print the version. If this line runs and prints a number, your engine is installed and warmed up. We're on TensorFlow 2.16.1 here. Now we build 3 tensors by hand with tf.constant, a scalar just the number 7, a vector 3 values, and a 2 by 3 matrix, 2 rows 3 columns, 3 boxes 3 different shapes. Here's the label reading habit. For each tensor we print its dot shape and its oddity type. The scalar shape is empty parentheses, 0 dimensions. The vector is 3. The matrix is 2 by 3, and because we typed whole numbers, the d-type came out as 32-bit integer. The label is right there, read it. Now the math, and notice these are two different operations. Apples B adds element by element, same shape in, same shape out, but A at B is matrix multiplication, rows times columns, and that's the operation a neural network does millions of times. The at symbol is the giveaway. That's the engine's favorite move. At.reduce mean collapses a whole tensor down to a single average. We feed it the numbers 1 through 6 and it hands back 3.5. Reduce is the word to remember. It means squeeze many numbers into fewer, and you'll see reduce sum, reduce max, the whole family all over this course. Two tiny but vital moves. tf.cast changes a tensor's d-type. Here we turn integers into floats because most layers want floats and refuse to mix types, and numpy hands the value back as a plain numpy array. You can print, plot, or hand to the rest of Python. That's your bridge out of TensorFlow whenever you need it. And the punchline, in one line, Keras sequential dense. We've built an actual model, a single dense layer with one output. We're not training it today. The point is simply that the steering wheel is always one import away. Everything fancy we build later, LSTMs, attention, full transformers, starts exactly here. So that's the foundation. A tensor is a labeled box of numbers, TensorFlow is the engine, Keras is the wheel, and the whole course is 8 stops on one track. Collect, preprocess, build, train, evaluate, save, deploy, predict. You're standing at the start of it now. Next time we don't just look at the map, we drive the whole loop in one sitting and build your first end-to-end model. See you there.